Good afternoon, ladies and gentlemen. I kind of wanted to help you guys out on those two first problems. I know that they're long and they're tedious, and just to make sure we understand what we're doing, I know you guys had to do 7 and 9. Let me do 8 and kind of show you what I mean. So let's take this. I will, well, first off, before I do that, and I'll put number 8 into this part right here. So first off, when you see a chart that looks like this, we have to understand what our intervals are. So if we have an x going from negative 1, 0, 1, 2, 3, the intervals that we're talking about is we're talking about the intervals from negative 1 to 0. Well, I should, though, put it here. The intervals we're talking about go from negative 1 to 0, from 0 to 1, from 1 to 2, and from 2 to 3. So they're just talking about just for those intervals right there. So after you find after you know what your intervals are, we're talking about to find our average rate of change for each. Yeah, that's how you spell it. So the way we actually do that is we find out what we need for each one. Now notice something, that if we make this our x1 and this our x2, notice how I just went from here to here. I made this x1 and I made this x2. So from there, I can actually deal with some problems. I can deal with some things to help. What you'll notice is that very similarly, the same way we have x1 and x2 here, we have that down here. We have f of x1 right here and f of x2, because notice the first row is our x's and f of x is basically the result once we plug that into our function. So as you can see down here, I have f of x1 equals negative 1, f of x2 equals negative 0.5. So if we're using the formula or the slope, if we're trying to find the slope, that's f of x2 minus f of x1 over x2 minus x1, then we're just plugging that stuff in, meaning that the first thing we're doing is negative 0.5 minus, we have negative 0.5 minus negative 1 all over 0 minus negative 1. In the top you should get 0.5 and in the bottom you should get 1. So our rate of change, our average rate of change, you can say that m being our average rate of change or average or slope, you can say for that interval your average rate of change was 0.5. Now you would have to do that for each one of those. So say the next one we're going to deal with is our next interval, 0 to 1. So if we're talking 0 to 1, then that means you're going from here to here. In other words, now this is our x1, this is our x2, meaning that this right here is our f of x1, and this is our f of x2. So the new problem we come out with is now we have that f of x1 equals 0 and f of x2 equals I'm sorry, f of x1 doesn't equal 0. F of x1 is going to be negative 0.5 and f of x2 is going to be 0.25. So now that means our function is, so now with our function, that means that once again we're doing f of x2 minus f of x1 over x2 minus x1. And we are dealing with 0.25 minus negative 0.5 all over, what's that, 1 minus 0? 1 minus 0. So that means that our average rate of change in this case right here would be, hold on, let me get my pencil. Our average rate of change in this case right here would just be 0.75. So let's go for the other one now. So now we're dealing with the interval. The interval we're dealing with now is 1, 2. So that means that our x1 is 1 and our x2 is 2, right? So if that's the case, our f of x1, as from the chart, is 0.25. And our f of x2 is 1.375. So now the problem that we're doing is 1.375 minus 0.25 over 2 minus 1. And with that, you should get 1.35 over 1. So let's mark that now. Hold on. So now you should get that. That means you have 1.35 right here. And we have one more to go. I need another color. Let's go with purple. You can see now that we're dealing with the interval from 2 to 3. So if we're dealing from 2 to 3, this right here being our x1, this being our x2 now. Notice your x1 and your x2 changes with every interval. So that means now our f of x1 is going to be 1.375. And our f of x2 is going to be 3.0625. So with that, the problem we're doing now is 3.0625 minus 1.375, and that is all over 3 minus 2. So I should get 1.6875. So going down here, my next is 1.6875. So as you can see, I got my average rate of change for each interval that I'm dealing with. And you can tell that the slope, as you're looking at these, the slope keeps on increasing, right? It's always positive, so that means that the function is actually increasing, looking at this. And let's see how fast it's increasing. It's going from 0.5 to 0.75 to 1.35 to 1.68. It's not really going that fast. So if in fact it was a graph, being that the slope is not really, it's increasing, but it's not really, it's slowing up as it goes higher and higher, then the graph will kind of curve off a little bit after a while. The slope is going to just flatten out after a while. And if we went and did more, analysis, you'll actually find that the slope levels up a little bit. So I want to show you what I would write up about this function right here. Hold on. I would say the average rate of change is always positive, so the function is increasing. Actually, I kind of made a mistake. I want to go ahead and correct that mistake before we continue. More that I'd write up. Hold on. Here I actually want to make a correction. The function won't necessarily look like that. Like this. Let me scroll up a little bit first. It's not going to necessarily look like this. The reason why is because the slope keeps increasing. So if the slope keeps increasing, I guess the steepness of the line keeps increasing. The way I had it drawn, the steepness of the line keeps decreasing. So really, if you had a graph, the function would actually look more like this, but it will actually increase a little bit slower because it's not increasing that fast. If it was increasing fast, if the slope was increasing fast, then it will be actually, the curve will be a lot more exponential. So it would be like, it will go up really, really quick. But since it increases slow, it's not as much. So, I mean, after something like that, you guys can say something like, after saying that the function is increasing, the average rate of change is slow, so the function is not increasing at a fast rate. So really, if you write something like that, I'd be okay with that, just to really give the general idea of what's going on with the interval, what's going on with the slope and everything like this. I hope this helps. Please contact me if you have any other questions or problems with this video. I'll be glad to help.